let's say that we run a car dealership and we have 11 salespeople. And we record the number of cars each of the 11 salespeople sold in the past week. So this is, that's one of them, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we record how much each of them sold. So maybe one person sold, maybe they sold 5 cars. Maybe the next person sold 7 cars. Maybe the next person sold 10 cars. And so that's how we would do it. So we're going to record all of that. But then we're told that the median car sold is 6. So if we ordered all of these numbers, so let's just assume that we ordered them all from least to greatest. So maybe, and I'm just making up numbers here, maybe this is 4, this is 4, maybe this is 5, 5, 5, 6, 7, 7, 8, 9, 10. The median car sold means that the middle number here is going to be 6. Now, we don't know whether all of these other numbers are the actual numbers. I just made those up. But we know that the middle number needs to be 6. So let me just fill out only the middle number. So the middle number, if you have 11 data points, the middle number is going to have 5 on either side. So that's that one right over there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we know that the median, actually let me do that purple color. The median is going to be 6. Now, the other thing we know is that the range of cars sold is 4. And let's remind ourselves, the range is the maximum number of cars sold minus the minimum number of cars sold. And if we have sorted all of these out, if this is our max right over here, because we've sorted them all out, and this is our min right over here, our range is going to be our max minus our min. So let me write that down. So you take your min and your max, you have your range. Range is equal to the maximum minus the minimum. And they're telling us that that is 4. This range is 4. So the maximum minus the minimum. The difference between the number of cars that the most productive salesperson sold and the number of cars that the least productive salesperson sold, that difference is going to be 4. So given all of those assumptions, giving all of that information, I'm now going to give you a statement. And our challenge is, if we assume everything I just said is true, is this statement going to be true? Or is this statement going to be false? Or do we not know? So let me write this down. So is this going to be true, false, false, or do we not know? Do we not have enough information to say it's for sure going to be true, for sure going to be false, or for sure we don't know? And so I encourage you to pause the video now and try it out. All right, so let's work through it together. This is kind of a fun puzzle here where we've been given some clues and then we have a statement and we figure, can we make the statement? Can we say it's true? Or can we say for sure that it's false? Or do we just not know? So a couple of ways to tackle it. One way to tackle it is, well, look, one of the salespeople must have sold 6 cars. If the median sold is 6 and there's 11 salespeople here, the middle number here, that if we order it, one of them must have sold 6 cars. If we had an even number here, then that would be the average of the two middles. But if we have an odd number here, that is literally the middle number of cars that the middle number of cars sold. So someone sold 6 cars. So if we assume, and we're trying to find a world where someone sold more than 10 cars. So if someone sold 6 cars, is there a way with a range of 4 that someone sold more than 10? Well, let's just think about it. Let's just assume that the min is 6. We don't know that the min is 6, but let's just try it out. If the minimum is 6, what's the maximum going to be? Well, remember, the range is equal to, we know that the range is 4. The range is equal to the maximum minus the minimum. Maximum minus the minimum. And so the maximum in this case would be 10. Max would be equal to 10. If the min is equal to 6, and instead of colons, I'm going to write an equal sign. If the min is equal to 6, then the max at most can be equal to 10. And we can't take a higher min because we know that the 6 is going to be one of the values. We could try a lower minimum value. We could say the minimum value is 5 or 4 or 3 or 2 or 1, but then the maximum would go down even more because remember, the maximum is no more than 4 larger than the minimum. So if we assume 6 and we know that one of the salespeople sold 6 cars, then the maximum that any of the salespeople could have sold is 10. And so the statement, at least one of the salespeople sold more than 10 cars, that's got to be false. That's got to be false. Now, there's another way that you could think about it. You could assume that someone sold more than 10. You could assume, in the last example, or the last way of thinking about it, we assumed that the min was 6. But now let's just assume that someone sold, let's just try it out. Let's see if it's possible. Let's just assume that the max is 11, that someone sold more than 10 cars. If the max is equal to 11, what's the min going to need to be? Well, we just have to remind ourselves, range is equal to max minus min. So 4 is equal to the maximum, 11, minus the minimum. So 11 minus what is equal to 4? Well, 11 minus 7 is equal to 4. So if we assume that the maximum is 11, then the minimum is going to have to be equal to 7. Now, can the minimum be 7 and when your median is 6? No. If your median is 6, that means if you have an odd number of data points, that means one of the data points is 6. And if you had an even number of data points, that means that the middle two are going to average out to be 6, which means you even have data points that are less than 6. So your minimum can't be 7. You're going to have a value that is at least as low as 6. So your assumption can't be true. Can't be true. So once again, the assumption based on this statement can't be true. This statement is going to be false.